Hey everybody, this is Larry, this is me going with Q4 of the bi-weekly contest 121, count the number of powerful integers. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem and this contest, everything in between. I took a while on this one just because I was just so messed up from mentally, like from not getting enough sleep or something, as you saw from the other problems if you watched the other videos. But yeah, overall, this is, to be honest, one of the straightforward dynamic programming problems, or not straightforward, sorry, but like for its class of dynamic programming problems, it is straightforward. Not to say it is easy, just that I think it is a pretty good problem with respect to learning about digit DP, in fact. But the way that people call this is called digit dynamic programming, and that's basically, I'll write it out, no worries. And that's basically, if you want to search for, I don't know if you could search for this easily on Google, but we'll go over the concepts and ideas, or at least on a rudimentary level, very quickly. But the idea really is just brute force, and the idea behind brute force is just that and once you kind of have done this a few times, you know, this one should be more straightforward. And for digit dynamic programming, this is probably one of the best problems to as a learning problem, because it is one of the most straightforward one. There aren't like any complicated there may be, it's not super easy, but it is definitely not a crazy thing. But yeah, the idea here is that, well, okay, so one quick idea that I also mentioned, but I kind of didn't go over it because it's not the hard part, is getting the range, right? The range, I don't know if you would consider it a trick, but it is something that happens a lot, so maybe you could consider it a trick. I don't know. For me, it is just a core idea, right? Which is that to get a range between start and finish, let's say you want to do start to finish inclusively, then it is, and given that this function so you want to calculate some f of, maybe f of is not a good idea, but basically the idea here, and you have some function f that is monotonically increasing, right? Or like, you have one, and the idea here is and you can make this monotonically increasing by making a prefix sum, and that's basically the idea, is that this is just equal to f of finish minus f of start minus 1, where f of finish, or f of x, I want to say, is equal to the number of powerful integers, I think they call it, from 0 to x inclusively, right? So basically now you can think of this f of finish, or let's say f of x is equal to, then now f of, or maybe not f, like another g, where g of x returns, I guess, is equal to 0 if not powerful, and 1 if powerful, right? And now you have g of 0 plus g of 1 plus g of 2 plus g of 3 plus g of x minus 1 plus g of x, right? So then f of finish is going to be all this stuff, right? Plus plus g of finish, right? And then f of start minus 1 is going to be the same thing, right? Except for obviously start minus 1. So then now let's rewrite this a little bit cleaner. Right, this is start minus 1. This is going to be start minus 2, right? Plus g of start, right? And then now you can also rewrite the top slightly differently, in that you have this thing, right? So then now you can see why f of finish minus f of start minus 1 is just equal to the top minus the bottom, and sorry, I don't know why. So then now it's just equal to this part, right? Which is what you want, the number of powerful numbers between start and finish inclusively. Okay, so this part, I know that I went by really quickly. You can rewind, you can slow it down. I don't think there's that much more to it, but this is the core idea about, you know, to kind of make this problem easier, so you only have to deal with solving calculating this thing twice versus playing around with bounds and so forth, which can be very difficult. But yeah. But yeah, okay, so then now, how do you do this? This is the dynamic programming part, right? So to calculate f of x, the idea, I mean, this is just the idea. We'll go over the actual implementation and dig into it a little bit more. But the core idea is just brute force one digit at a time, right? And what I mean by that, so let's say, let's take, all right. Okay, let's just do the input for real quick. So let's say we have 6,000, where s is equal to 124. Limit, I guess this limit is 4, so okay, fine. It's slightly easier to read, but it doesn't really matter, right? And the idea is that, okay, now you go up to 6,000, you have 4 digits, right? So the first thing is to brute force the first digit, and the first digit could be 0. It's a leading 0, it's fine. And then we have the rest of the digits, so I'm just gonna dash it out for now. And then you could do and then 6 is a tricky thing, because now we have to consider it a little bit differently. But we'll skip that, or we'll come back to it later, right? And then now this is just brute force, right? So then now you start with 0, 1, 2, 3, 4, 5. And basically what happens, the rest of the numbers have total freedom, right? Because it can go, well, okay, I'm going to change the limit to 9 for now, because it complicates things a little bit unnecessarily. But yeah, let's say the limit is equal to 9. Then here we have 0, 1, 2, 3, 4, 5. And let's actually add a number real quick. Add a digit so that I could visualize it a little bit better. Yeah, so let's say you have 60,000, limit is equal to 9. Ooh. And s is equal to 124. It doesn't really matter what the prefix is, right? But what does this mean? That means that every number after that could be from 1 to 9, or 0 to 9 even, right? So then now, let's say recursively, let's go with this. Then now, yeah, in this case, the next digit. So then you go 0, you go 0, 1, and so forth, right? And it turns out that for this problem, it actually doesn't matter what the first digit is, right? Because all these numbers, they add up, it doesn't matter. So now another way to write this is that, you know, you have this thing, at least for now, until we get to the suffix, that the prefix doesn't matter, because, yeah, it just, so then now you also do the iteration on the thing. And here you have more freedom all the way to 9, right? And that's basically the idea about digit DP. If you ask about how to brute force, is one digit at a time, hence the name digit DP, because the previous digits don't matter in the state. Yeah, because how many you know, in this suffix, how many answers can you get does not depend on the prefix, right? You're just solving it for the suffix. And then you could do this recursively until you are reaching the pattern, right? So then now, let's say, let's go back up. So let's say here, and then now we go, okay, let's go we do recursion. Again, the prefix doesn't matter, so I'm just canceling that with the dashes. Or maybe I should have done stars, I don't know, it doesn't matter, right? And then now you have, it has to be, we check that this has to be a 1. So what does that mean when it has to be a 1? Well, that means that, well, you have no freedom. This has to be a 1. So now you start with a 1. And then with this 1, you know, you can do other things, but one way to do it is just recursion again. And yeah, and here, technically, you don't care about the previous digits, and you could write it that way, and we will write it that way. But because we have the assumption that the previous digit is equal to the pattern in this problem, so we can just write it as 1. And then the next digit is also forced as a 2, and then the next digit is also forced as a 4. So then now this means that there's a 1, you know, this has one powerful number, and then now you can say that with this prefix of 0, you have one powerful number, and then here you sum up all the other ones and so forth. All right, so that's basically the idea, and of course, without the upper bound, so I'm just right, upper is equal to 60,000. Without the upper bound, this makes sense. This is straightforward. Hopefully, just brute force. So then, now what happens with the upper bound? Well, the first digit, for example, you have to say it only goes up to 6, right? Because you cannot do 7 because this is 0, because it's just bigger than the upper bound, right? So then now here, you now do a recursion. And what do you recurse on? You do a recursion on, let's actually change the upper bound a little bit as well to like some whatever, right? And then now you do recursion on the same idea that I read before, which is that now we match the first digit. You can write this in a number of ways, but we match the first digit, and then the second digit, we brute force again every digit, right? So we go 0, we go 1, we go 2, we go 3, and then we go 4. And this logic actually is the same, right? Because now on the next digit, let's go 60 real quick. Actually, after here, we don't care about the previous digits. The rest can be any number of digits. Of course, we have to reach these constraints, but that's basically the idea. If you have more numbers, then, you know, let's say we have more digits, then now here, again, we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever, up to the limit, and we don't have to constrain it. So that's basically the core idea. But on the 4, that's when it differs, right? Again, because 6, 4, it matches this upper limit. So then now we can only constrain the rest of this. And again, because we matched it before, you can say it in a number of ways. But the next one is just gonna be 0, 6, 4, 1, and this one, you know, also matches. So it has a constraint. And of course, you also have to match this. And as a result, there are more if statements and exhaustive cases, and we'll go over that in code. But that's basically the core idea behind digit DP, is that you're brute forcing the digits one at a time. And the brute force is kind of constrained in a way that depends on the problem. For this one, it should be easy to... for digit DP, this is one of the easier problems, so this is a good place to start and good place to practice. Yeah. Let's see. Yeah, and then now let's go over the code. So that's basically the idea. This part, as we said, you know, we just kind of do the finish and the start. -1, we already gone over it. I think this is pretty straightforward, so I'm going to leave it here. And then now here we have f of x of s, and again we calculate once for start -1 and once for finish. And this is just basically a lazy thing, which is if the pattern is bigger than x, then we return 0. I don't even think this is necessary. I hope not, because otherwise that means I have some code that is maybe broken. But yeah, but otherwise, if we ran out of digits here, that means that we match everything. Then the length is going with the suffix. Then we turn 1. Oh, wait, I skipped some stuff. Oh, here I just kind of added a dash. Maybe as a star. It's just to kind of match up the length so that I can kind of match up the x and the suffix. And you'll see how I use it later. But yeah. And otherwise, we return the first digit, and we want to start off with constraint. I call it match, but maybe and this is where I got some confusion. Maybe this should be a constraint. So that means just saying that the next digit can be constrained. Is that? Yeah, right? Meaning that it can only go up to limit. So if constrained, the next digit can only go up to x of index or something like this, right? So that's basically the idea, because now another way to think about it is that this is the prefix matching. So that's why I had match. I don't know which way is clearer, depending on how you want to think about it. But yeah, basically if we went through all the digits, then obviously we're done. So we have one way of doing it. Otherwise, we just sum up the total. If it is, let's skip the constraint part first. This is the free part, right? So then now we only have two cases. We have either the suffix is constrained, or we have to match the suffix pattern, or we don't. So if we don't, then we can choose any of the limit plus one digits, and then we just recurse to go to the next digit. Oh, I guess in this case I have to rename this. Though this is just false, right? Because if this is false, then this will stay false. Otherwise, if it is not a wildcard, then you just go to the next one, because basically you're choosing that one digit, right? So let me write this, right? Let me comment this while we talk, so then we can, so yeah, you can choose any of the digits from 0 to limit inclusively, which is why you have limit plus 1. You are forced to choose s of index. Yeah, s of index, right? So that's basically it. You're choosing that number, so then that's why you just, you just add it once. Otherwise, okay, we're constrained it. The prefix matches. So then now you look at what the current number is, and then here is just case analysis in that way. Is if wildcard, then now again you can choose any of the digits from 0 to limit, or occur, or x of index, you want to write that way, inclusively. That's how you have this function, and then this is just going forward. Otherwise, can we choose x of index? Next in the current digit. And if you can, then you still constrain it. That's why you have a true on this thing. And then yeah, that's pretty much it. And you can't go over it because you have the prefix here. If you have 6.4 as a prefix, you can't do 6.5, right? So that's basically why it stops here. And also it goes to see if you can do that number exactly to go to prefix. Otherwise, this is where I got two wrong answers. I think I just didn't think it through because I was lazy and such. But yeah, I mean, as I said, this is also just kind of going through the cases, and this is where I got wrong answer because I did during the contest. I think I was just so out of it at this point. I just kind of guessed, which is kind of silly because I can just spend 1 minute to think about it. But instead, I got two wrong answers, so that was silly. But yeah, you are forced to choose s of index, right? And then basically, with constraints, if they are the same, then and we have to care about the prefix still. If not, this is the part that where I just didn't think through. Pick s of index only if s of index is smaller than x of index, because they're not the same, right? Really. So if there's not the same, but then it's not constrained anymore because on the next digits you can choose anything. And the way that I would actually think about this, and I didn't do this during the contest, like I said, I was being sloppy, is just use examples to yourself, right? So then now here you can say maybe you have 6.4, let's just say, yeah, let's say you have upper bound 1 to 5, right? And your thingy, and you're up to here. Then now, if they're the same, what happens, right? If they are the same, then we just go to the next digit, so that's fine. And for this case, I think this is where I should have done it. What have done? Then now you have, if x of index is greater, then this can be chosen, so then you go false. And if this is smaller, then you cannot choose it, so that's why it's equal to 0. And also that this is false because now you can even use this to visualize. I think I did this one by accident. Whoops. But yeah, if this is bigger, then now this can be any number. I just write star as for any number. So that's why this is false. And that's basically the idea. That's pretty much it. It's like I said, I don't know that I wouldn't say that this is easy. I mean, it took me half an hour and 2 wrong answers, so it's hard for me to say it's easy. But given this class of problems, digit DP, this is as easy as it will probably get. I need more practice, or maybe just sleep, to be frank. But that's besides the point. But yeah, let me show you the entire code really quick. Let me make it slightly smaller. I mean, maybe I don't have to show you the entire code, but this is the core part of it. The bottom is pretty easy to see. The top part, this is just padding, and then the actual DP is in here with comments. So yeah, that's all I have for this one. Let me know what you think, and yeah, you can watch me solve a live in contest now. I am just really off today. The ideas are still there, but coding wise, I just obviously not. Should have skipped this one. I said that last time, but oh. Alright, 5 people already solved it, so hopefully we're able to solve this even if, you know, the running time is terrible, or the penalties are terrible. Alright, let's actually read the problem instead of just looking at the examples. Ends of S is a suffix of X. Okay, so you want something that ends in 1, 2, 4. Each digit in X is the limit at most 4. Okay. This seems pretty straightforward, or am I missing this? How badly am I anyway? I am not doing well today. Is Alex up there? Did I just saw Alex? No. Okay. Well, the 3 penalties is going to be terrible. Alright, focus. 10 to the 15. Okay. Okay, and it is just I don't get it. I don't get why this is. Man, I mean, it's prefix DP, but I'm just like, I don't know. My brain is not good enough right now. Just do it. X is and first digit. they're the same number of digits. I don't remember what it states. Yeah. Just trying to see how many people solved this one. I don't know. I would imagine people have solved this already, to be honest. A lot of submissions, so maybe there's some edge case that I'm not, which would not be great because my first Q3 is pretty bad. 3 Qs. The prefix doesn't matter. Oh, I can't do this, can I? Because you care about the prefix. As does not leading zeros, but syntax. I'm so bad at this today. Okay, so now. No, I forgot about limit, actually, but I guess that's fine for now. Then now we count the current. No, that's fine. That's just this constraint. It's not a match. Match is on the prefix. Alright, let's focus. Okay. Alright, let's just write it out. 0, and now. How do I want to write it? We start with zeros first. Okay, yeah. What is match again? Oh, match the prefix. Okay, fine. Okay. Now this is the current digit. So this is the freedom. Actually, I want to do this inside. Okay, recount. So it could be 0, 1, 2, and then it was not match. Maybe this should be true. Okay, let's say this is not matching in terms of all the freedom. Okay, but we want to match. Then now we have to match an index. Or the previous one is matched. So then now we want to say it only goes up to the limit, right? Then now we have x of index. That's correct. This could be a multiplication, but okay, fine. Optimize later. Okay, so it goes up to cur. Okay. I still have to take account this thing. Okay. then we can do whatever we like. Except for in one of the current range. Okay. Else, then it has to be this number. Else, if current is equal to n, then what happens if it's the same? This could have been whatever, but okay, fine. Yeah, well. Oh, wait, wait, what? Why did I take it out? I forgot. I was trying to and then I didn't finish it. I think it's fine now. Oh, I don't have a base case. Why does it take that long to give me an error? Yeah. Not gonna lie, if there's server issues, that would be great. Uh, 620. Oh, I got 5. Okay. Why is this giving me 1? Oh. Well, the 7 is wrong anyway, but maybe it's related though. 4. Oh, if this is longer than that, okay, fine. Does this work? Not really, I guess. Okay, I mean this is fine, but why is that returning a 1? Let's see, oh, I guess actually it's more reasonable, which is but I don't know if that's enough. I mean, that's enough for one part of it. But yeah, I still have to figure out the other part. That's just kind of a hack. I think my thing is still a little bit wrong. 3 people cutting it. Okay. Alright, let's see why my thing's not working. 7. Could be 7 as well. Oh, see what goes. Let's see what we try. 1, 2, 3, 4. Okay, we'll try 0. 1, 2, 3, 4, 5. Right? Oh, to limit. So okay, what does that mean? That means that there's this part. Limit plus 1, so that should be 0, 1, 2, 3, 4. So that should be 5. Why is that not 5? Tell me why. And it should be all. Okay, so this is true. Oh, there's some like weird thing I'm doing here. This should be current index is 6. That's fine. Oh, and this is min of this. Huh, I didn't know that limit. Okay, fine. Okay, I mean, now at least it should be much closer. Right, and then now I add this part for no, or not necessarily any reason, but if cur is less than limit, okay, I mean this is probably still wrong, but I have too many penalties anyway, so I'm gonna YOLO it just to get a test case. I guess that's actually not a bad, but I'm getting lag, or I don't know, the service issue, but okay. Yeah, right now I'm just trying to get an AC. I don't really care about it. All right, 972 and 72. Okay. Maybe I have some. I think I did have suspicion about this one, but limit is 9. Not yeah. Okay. Okay. This should not be. One of these should not be 1. The prefix. So if this matches, it only goes up to. Okay, so it matches. Why did I have this? This doesn't even make sense. That's. Is this right? I really want to. That didn't make sense before, that's why I'm struggling a bit. Okay, so if the prefix matches and you have a thing. Yeah, okay. That actually didn't make sense before. I think I'm just kind of rushed it a little bit. Didn't I? Oh no, this is a different one. Well, this is a mess of a time test. I mean, at this point, I'm just trying to get it done, but Though maybe I should at least pay attention a little bit. This should be 10, but it's 9. Okay. So yeah, that makes sense. Okay, but it needs all the prefix. So one more. No, that doesn't make sense. Nine, 7 is 0. That's true. Okay, fine. Did I just messed up? 0, 9, all the way to 9. Limit +1. Zero, 1, 2. No, that should be 10. Why is this like wrong? And would that be similarly wrong here? I don't know, that's right. This is 9 is right, and then we... Did I just forget the prefix on the limit? Oh no, this is on a not match, so it's this part. So I have to do this. No, and it does it. So it's this part wrong. So it goes to 0 to 9 and also 0 to 9. So 0, 1, 2. Okay, so that part is right, but then it does here, right? So it does do this here. Well, but this returns 0. Is that true? No. Because basically you have 1. Oh, Alright, my cases are a little bit off. Okay, I see. That's why I had this thing here. Okay, so the prefix. So, okay. I need another case. If the current, I think current is a terrible name. I think that's why I got confused. I think the answers are backwards, so that's not right. If the current number is bigger than the digit, oh yeah, then now we have the freedom to choose the digit, choose SIN, but now without the prefix. Okay, man, I am just like really bad today to work through the logic. Kids, do contests after you get enough sleep. I mean, okay, well now it's just not even showing me where to, oh there we go. Oh, there we go. So actually I was very close. I got most of it. I just kind of had one thing. So which is kind of not bad. I mean, considering my... Thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest, this problem, the explanation, everything in between. Had a rough contest, so definitely would appreciate the support. So yeah, I'll see you soon. Thank you. Bye-bye.